lines and triangles starts with this postulate. It's called the parallel postulate. It says through any point not on a line, there is exactly one line parallel to the given line, okay? And I didn't leave a lot of room there, so I'm going to draw it up here. Let's say I have a line, and I have a point right here, okay? The parallel postulate says there is only one line that I can draw through that point right now that will be parallel to the given line. Do you see where that line should be? It would be that line, except for I messed it up. That's the only line that is parallel to the given line that goes through that point, okay? And that comes into play in a little bit here when we do our proof, but I'll talk you through that in a minute. And then the other thing that we're going to talk about today, and this is the one that you should already know, is the triangle angle sum theorem. It says the sum of the measures of the angles of a triangle is, if I add these three up, 180, right? A triangle will always add up to 180 degrees, okay? Okay, so what we're gonna do here is we're gonna prove that that is true. Here's how. This is a lengthy proof, you guys, but I'm just doing, this is just me proving to you that triangles add up to 180, okay? You don't need to ever do this again. I'm just showing you why. Can you take a picture? No, you can write it down. I mean, you should write it in. You should write it in, because then you're thinking through it with me. So the first thing, it says, given that, oh, I need to give you one more thing. Write this up in the given. PR is parallel to AC. I'm shortening the proof a little bit for you, because it's already a really long proof. So I'm going to give you more information than the book would have given you. So given that triangle ABC is your triangle and PR is parallel to AC, okay? So the first thing you can do is just take that, drop it here. What is our reason? Given. First step of every proof is the given. Okay, so we were just told that this line is parallel to this line. That was given to us. Okay, so I would mark it just to remind yourself as you're looking through this that that is true. If you look at let's look at it like this. So we have this straight line PR, okay? If I call this angle PBC, right? So angle PBC, actually I'm gonna call it the measure of angle PBC plus the measure of angle, you can either call it angle 3 or you can call it RBC. What do you prefer? RBC. Okay, if I add that bluish angle to this red angle, what should they equal? 180, yes. Those two added together are gonna equal, oh, you know what, I just took a step out even. We're gonna make this a 6-step proof. I just shortcutted us. So if I know those two added together equal 180, why do I know that? Not because a triangle equals 180, because those don't make a triangle. They're supplementary because they're a linear pair, okay? So I would just call this linear pair. Technically, I should have started with the linear pair, gone to supplementary. I'm shortening the proof for you. You're welcome. Okay, so the next thing we're gonna say is the measure of angle PBC is equal to angle 1 plus angle 2. The measure of angle 1 plus the measure of angle 2. Do you see that? The bluish color angle, PBC, is equal to angle 1 plus angle 2. Anyone remember what that's called? We did it in chapter 1. We did it last chapter too. No. Angle addition postulate, right? That's the angle addition postulate. If you add the two parts together, You get the whole thing. Okay, angle addition postulate. Okay, so now think about this. I just told you that 1 plus 2 is PBC. So if I go up here, oh, here's why we should have called it angle 2. I'm just backtracking on everything right now, you guys. Call this one up here angle 2. You'll see why in a minute. It makes more sense. Not angle 2, angle 3.
What the?
Wait, what?
So wait, what are we doing? Wait.
Okay, rewind.
Measure of angle PBC plus measure of
We didn't
angle
mess up.
PBC.
I'm trying to shorten it for you, and if I don't call it angle 3 right now, you have to take another step. We don't want to take another step. Just go up to step 2 and replace your RBC. I let you choose. I shouldn't have let you choose. Call it angle 3. Okay? I'm sorry. I'm not trying to offend. Just trying to make this as basic for you as I can. Okay. So now here's the thing. I know that PBC is 1 plus 2, right? So that means if I substitute angle 1 plus the measure of angle 2, sorry. I'm just rewriting this right now. I'm rewriting step 2 with substitution. So I'm putting in the 1 plus 2 in place of PBC. So measure of angle 1 plus the measure of angle 2 plus what we still have there, the measure of angle 3, should equal 180. Okay, 1 plus 2 plus 3 equals 180. That was just substitution. Do you see it? I just substituted what we knew it equaled. Okay. Okay, so now think about this. 1 plus 2 plus 3 equals 180. Do you see anything that angle 1 is congruent to? Which one? 3. Might be 3, but we don't know that for sure. There are types of angles that you learned in the very first lesson of this chapter that are in this picture. We know the lines are parallel. What kind of angles do you see?
Acute.
There are acute. There's no vertical angles.
Angle A?
Angle A, yes. We know that angle 1 is congruent to angle A, right? On that same note, we also know that angle 3 is congruent to what? 3 is congruent to C. Those are alternate interiors for both of them. Okay? So, now think about this. We said that 1 plus 2 plus 3 is 180. If I put A in place of 1 and I put C in place of 3 by substitution, right? Sorry, these were alternate interior angles on number 5. If I substitute now, look what they asked us to prove. The measure of angle A plus the measure of angle 2 plus the measure of angle C should equal 180, which it does, and that is just substitution again. Okay, so that's how they came up with a triangle should always add up to 180. They just used a straight line. Did you know that if you take a triangle, have you ever tried this? Let me show you. So good. Okay, so please don't stress about this. This is just me proving it to you. I will never ask you to do that again, ever, again. What I will ask you to do again is this problem. You'll do lots of these, okay? And these ones should be pretty simple if you stop and just think about what we know and what we're working with here. Let's say we have this triangle and we're trying to solve for X, Y, and Z. Yes?
What was the reason for number 6 again?
Substitution. Okay. So X, Y, and Z are what we're trying to solve for. You need to look for triangles. How many triangles do you see in this picture?
2. 3.
There's 3, right? There is this triangle, right? there is this triangle, and then the whole thing, this triangle. Right? So there are 3 triangles here, which means there's 3 different scenarios that you can work with to come up with 180 degrees. Okay? So if that's the case, let's look first at this triangle. How do you find x? X plus 59 plus 43, right? The 3 angles of the triangle added together should equal what? 180. Okay? So you're just going to simplify this. This is, what is that, 102? So x plus 102 equals 180. So take away the 102, and you get x is 78. Okay? So that's your first one. X is 78 degrees. Go ahead and put a little degree up there every time. X is 78. Does anyone see how you could solve for y right now? Because it's not going to work to set up a triangle, but you know something that will help you solve for y. Let me give you a hint. There's your hint, John.
Okay. I got it.
You add x and y, not plus z, right? We know this one's 78. We just found that. That's a linear pair. What do you know about a linear pair? They're supplementary. They add up to 180. So now that you have x, you can say 78 plus y should equal 180. So take away the 78, and that means y is 102. Okay, and these are super helpful if you write the numbers in that you know, because then you can see where to go with them. Okay, so y is 102 degrees. Now z, you have 2 options. Do you see the 2 options? You could use the big triangle, right? You can't do same side interiors because we don't have parallel lines, right? You have to have parallel lines for that. But we could use the big triangle. And if you use the big triangle, then it's 59, 43, and 49 together make that top angle, and then z, okay? Or what I think is easier is just use this triangle instead, right? In this triangle, we have 102, 49, and z. So 102 plus 49 plus z has to add up to 180. So this is 151 plus z equals 180, and then just take away the 151. So z is 29 degrees. Questions on that? Okay, something I want you to see is we got this 102 up here. We also came up with 102 right here. There's a relationship there. I'm going to tell you about it right here. Exterior angles, okay? We're going to talk about 2 different types of angles, exteriors and remote interiors, and they are connected. They are linked together with just a relationship. The first, exterior angle, that's an angle formed by a side of your triangle and an extension of an adjacent side. So a side next to that, okay? So let me just show you in this picture right here, a side of our triangle right here, and the extension of a different side. So I kept that going. The angle that was formed is angle 1. So angle 1 is considered an exterior angle. Okay, I'll just show you another picture just for the sake of grasping it. If this is my triangle, if I extend this side, the angle that it forms with the other side of the triangle, this side right here, is an exterior angle. Is this an exterior angle? No, because that's the extension and the same side, right? It's just one side extended. That's not exterior. So you have to extend one side, use a different side. You get an exterior. Okay? Then there are what we call remote interior angles. Now think, if you said, I'm going away to a remote desert or a remote tropical island. What does that mean? Far away, off by itself, like secluded, right? So that's how you need to think about these remote interior angles. It's two non-adjacent interior angles to the exterior angle. So they are not next to the exterior. They're away from the exterior. Okay? In other words, my remote interiors, like in this picture, are angle 2 and angle 3. This one is not remote. The little dot is not remote. It's right next to the exterior. We want to be away from the exterior angle. So in this example, this one is the exterior, angle 1. These two are the remote interior. Remote interior. Okay? So this and this. Same thing here. Exterior, remote interior, remote interior. Okay, so it's not the one that's touching the exterior angle, it's the other two. Does that make sense? Questions on that? Okay, here's the thing. I'm going to tell you about a theorem. You don't ever have to use this theorem. There are ways around this theorem that you can always find the right answer. But I'm going to tell you about it. If you want to use it, go right ahead. This is the triangle exterior angle theorem, and it says this: the measure of each exterior angle of a triangle equals the sum meaning you're adding things together, right, of the two remote interior angles. Let me explain. If I'm looking at this triangle here, okay, this exterior, if you think about it, it's supplementary to this angle, right? Then think about the three angles inside. So if I call this angle 4, for instance, I know that 2 and 3, if I put them together, will also equal 180 with 4. So if they're both going to equal 180 with that 4, then they must be equal to each other. So angle 1 will equal the sum of 2 and 3. Okay, so if I take the two remote interiors and I add them together, it will equal the one exterior. Okay, now let me show you why you don't actually ever have to use this theorem, because I will show you a way that you can do it regardless of knowing the theorem. Using the theorem is easier. You will get there quicker, it's nicer, it's great. But everybody knows a triangle adds up to 180, right? So you can always get there using that instead also, okay? Look at this first example. It says find the measure of the numbered angle. So in this case, we're looking for what is the measure of angle 1. Angle 1, is it interior or exterior? Is exterior. And we just learned that the exterior angle equals the sum of the remote interiors. Well, my remote interiors are these two, right? So if I add these together, I can set it equal to angle 1. So we would say the measure of angle 1 equals 80 plus 18. So the measure of angle 1 is 98 degrees. Okay, that's using the theorem. That's quick, it's simple, there it is. What if you didn't remember that theorem? Does anyone see a different way to find the measure of angle 1? Julia.
You could add 80 and 18 together.
Let's call this X for now.
To make 180. And then angle 1 is supplementary to the missing angle.
Right. Okay, so here's your other option. If you forget this theorem, you have a triangle here. That means X plus 80 plus 18 is going to equal 180. So if I take away that 98, I get that x equals, what is that, 82. Right? So I know this is 82. And if I know that is 82, it forms a straight line with angle 1. So 180 minus 82 would get me the 98 that it is. Okay? Do you see how this is a lot more work? Right? More steps involved, but you can always get there. Okay? So if you forget remote interiors, don't stress about it. You can get there another way. Okay, now look at this second example. Which angle is my exterior angle? 124. And we said the exterior equals what? The sum of the remote interiors. So it's going to be 59 plus the measure of angle 2. How do you solve that for the measure of angle 2? Just subtract, right? Take away the 59. So 124 minus 59, that's 65 for the measure of angle 2. But like I said, you always have options. You could find this, 180 minus 124 would give us 56. Yes. So if I know that's 56 and I know I have a triangle here, 56 plus 59 plus the measure of angle 2 has to equal 180. Okay, so if you can't figure it out the one way, figure it out the other way. Questions on that? Okay, last problem is just more of a real world picture of what's going on with these. You have a radar receiver at A. Okay, so there's this tower, right? So there's a receiver up here at A. An airplane at B. And they call it the airplane's ghost. So if we reflect that over that horizontal, the horizon, the line of symmetry, the ghost is down here, okay? They want to know what's the angle from X to its location on the ground. The angle that that plane would come in at is 30, okay? So here's the 30 up here. They want to know what's the angle here. This angle, they tell us, is 80. What is X? It's 50, right. 80, the exterior, equals the sum, of the two remote interiors. This is a remote interior, this is a remote interior. So 30 plus X equals 80. Take that 30 away, and you get X is 50. Questions on that? Okay, that's what you're doing. Every triangle adds up to 180. Don't ever forget that. Every linear pair adds up to 180. Look for linear pairs, look for triangles. You'll be in real good shape. Okay.